Srinivasa Ramanujan was a self-taught mathematician that began his journey at 15 years old when he discovered the thousands of theorems in George Shoebridge Carr's book, Synopsis of Elementary Results in Pure and Applied Mathematics. He secured a scholarship to the University of Madras, but withdrew to his devotion to maths over other subjects. He then went on to wed in an arranged marriage in 1909 to a 12-year-old girl. With strong reference from E.W. Middlemass, Professor of Mathematics at the Presidency College in Madras, he secured his first job as a clerk at the Madras Port Trust. His first papers were then posted in 1911 in the Journal of the Indian Mathematical Society, and went on to work closely with Godfrey H. Hardy, despite setbacks due to being Orthodox Brahmin. He graduated in 1916 from Cambridge with a Bachelor of Science by Research and continued to publish papers in English and European journals until his premature death from tuberculosis in 1920.
One highly praised contribution of Ramanujan's is his formula for the infinite series of pi. The formula is based on a negative fundamental discriminant d equals minus 232 and the fact that e to the power of pi squared root 58 equals 396 to the power of 4 minus 104.00000000177. To sum it all up, he's a genius. The pi series converges rapidly and is hence used as a basis for high-speed algorithms to calculate pi. Another contribution was his implementation of the circle method. The method is used to solve asymptotic problems in additive number theory. For example, the number of integer partitions for 5 is equal to 7. The circle method brought about advancements in both analytic number theory and the theory of modular forms. One of the many mathematicians he influenced was Ramachandra, the secretary of the Indian Mathematics Society. A big problem Ramanujan had was that other intellectuals did not believe in his academic integrity. However, when Ramanujan spoke with Ramachandra about elliptic integrals, hypergeometric series, and his own theory on divergence series, Ramachandra was amazed and allowed Ramanujan to publish his works in the Indian Mathematics Society journal. Another mathematician he influenced was G.H. Hardy, Ramanujan's mentor and friend while in Cambridge. A major obstacle Ramanujan faced was other mathematicians in England thought his mathematics wasn't formally laid out, causing them to reject his work. G.H. Hardy was skeptical at first as well, until he viewed Ramanujan's work on hypergeometric series, stating it was more intriguing than Carl Gauss's work on integrals. G.H. Hardy and Ramanujan published many theories in the Journal of the London Mathematics Society. Soon enough, he was recognized by highly influential people and was accepted as a Fellow of the Royal Society.
One of Ramanujan's theories, aptly named the circle method or Hardy-Littlewood circle method, was very helpful when dealing with number theory. This theory allowed solving of asymptotic problems by allowing one to calculate natural numbers written as a sum of s elements of a. This idea was used by Hardy and Littlewood when writing papers on Waring's problem, and has also been rewritten by the likes of Harold Davenport and Vinogradov, making slight modifications to the formulation, complex analysis to exponential sums, and is shown to still yield results. The circle method is shown to be critical when dealing with theta functions, an important part of quantum field theory. Ramanujan is also credited with the Ramanujan graph. These are graphs with spectral gaps as large as possible. Because they serve as excellent spectral expanders, meaning they have strong connectivity properties, they have piqued keen scientific interest in researching pure and applied mathematics. Several of these researchers going into robust computer networks, as well as error-correcting codes.